Welcome back to another deep dive from Peaceful Rooster Experience. Today, we're going deep into the world of processes and threads. These are the kind of like the fundamental building blocks of how computers get things done.
Yeah, that's right. And the way these building blocks are used has huge implications for everything from a computer's performance and security to even which database is best suited for a particular task.
Okay, so even though this sounds super technical, you're saying I don't need a computer science degree to understand this.
Not at all. Let's start with the basics. A process is like an independent unit, kind of like a self-contained apartment in a building. It has its own memory space, resources, and operates without interfering with other processes.
So if one apartment has like a plumbing issue, it doesn't mean the whole building is flooded.
Right. Exactly. That's the beauty of processes. They provide isolation and fault tolerance. If one crashes, it doesn't bring the entire system down.
Okay, that makes a lot of sense.
Yeah.
But I'm guessing there are times when you want things to be connected. How do threads fit into this picture?
Think of threads as roommates sharing that same apartment. They live within a process, sharing the same memory space and resources. This makes them incredibly efficient for communication and coordination.
So threads are all about speed and teamwork, like hopefully a well-coordinated group project.
Sure.
But you mentioned potential downsides earlier.
Right. With shared space comes the potential for conflict. Imagine those roommates, like all trying to use the same bathroom at the same time. That's similar to what happens with threads. We call those conflicts race conditions when multiple threads try to access and modify the same data simultaneously, leading to unpredictable and often messy results.
Okay, so threads need a bit more like management than processes. It's like having roommates where everyone needs to agree on the chore schedule to avoid chaos.
That's a good way to put it. And then there's another issue with threads called deadlocks. It's like two roommates blocking each other in the doorway, neither can move forward.
Those all sound like headaches for programmers. Are threads just inherently dangerous then? How do they ever get anything done safely?
Well, they're powerful tools when used correctly. Skilled developers use synchronization techniques, essentially setting rules and protocols to make sure threads cooperate without those conflicts. Think of it like establishing clear communication and coordination rules among your hypothetical roommates.
Okay, so there's more to threads than meets the eye. It's not just about speed, it's also about managing them carefully. So how do we know when to use processes versus threads? Is there like a simple rule of thumb?
If you need robust isolation and fault tolerance, especially when dealing with large amounts of data, processes are your best bet. They're like the heavy lifters, perfect for tasks like background processing or handling sensitive information.
Okay, processes for heavy lifting and security, got it. What about those high-speed situations where coordination is key? When are threads the better choice?
If speed and low latency are critical and communication between different parts of your application is essential, then threads are the way to go. Think real-time applications like online gaming or high-frequency trading platforms where every millisecond counts.
So threads are like the sprinters of the computing world. But it sounds like most real-world systems probably use, a combination of both.
You're absolutely right. Modern systems often take a hybrid approach. They might use processes for overall isolation and then utilize threads within each process to handle specific tasks efficiently. It's about getting the best of both worlds.
That makes sense. It's like having different departments in a company, each with its own kind of set of responsibilities and teams working together within those departments. But how does all of this affect performance and security? Are there trade-offs to consider?
Definitely.
Yeah.
Processes with their isolation tend to be slower to switch between, kind of like having to travel between those separate apartments we talked about.
Okay.
But that isolation also makes them more secure. They are less vulnerable to issues in other processes.
So processes are like fortresses, slow to access, but very secure. Threads, then, must be faster to switch between.
Exactly. Think of them as moving between rooms within the same apartment. The overhead is less. But as we discussed, those shared resources require careful management.
Ah, yes, those roommate conflicts. So I'm curious, how does the operating system manage all of this complexity? It seems like a lot to juggle.
Operating systems are incredibly sophisticated. They have what are called thread schedulers that determine how CPU time is allocated, essentially deciding which thread gets to use the processor at any given moment.
Oh, okay.
They also manage process priorities, ensuring that critical applications get the resources they need to respond quickly.
So it's like having an air traffic controller for threads and processes,
Yeah.
making sure everything runs smoothly. This all sounds very abstract, though. Can we get like a real-world example of this thread scheduling in action?
Absolutely. Think about your web browser. You might have multiple tabs open, each running different websites or applications. They all seem to be working simultaneously, right?
Hmm.
That's the operating system's thread scheduler, deciding which tab gets to use the CPU at any given moment, creating the illusion of simultaneous execution.
Okay, that's starting to make more sense. So it's like the operating system is constantly kind of switching between different tasks so quickly that it appears seamless to us.
Exactly.
But this all still feels, I don't know, pretty theoretical. I'd love to see how these concepts actually play out in the real world, especially with databases.
Great point. Let's delve into how specific database systems like Oracle and PostgreSQL leverage processes and threads to achieve their performance and stability goals.
Okay, now we're talking. Let's see how this all works in practice.
Let's start with Oracle, a database known for its power in handling large-scale enterprise applications. It's interesting because Oracle uses a combination of processes and threads in a very specific way.
Okay, I'm ready to hear how Oracle juggles all of this. Does it favor processes or threads?
Well, Oracle utilizes a process-based approach for handling connections. So each connection to an Oracle database, say from a Python program using a library like CX Oracle, spawns its own separate process.
So if I'm picturing this correctly, it's like each Python program gets its own dedicated, building in the Oracle city.
That's a great way to visualize it. And this has some key advantages. For instance, if one connection crashes, it won't impact other connections. Think back to our apartment analogy. One apartment having a problem doesn't affect the others.
Right.
Yeah.
That sounds incredibly reliable, especially for something like a banking system where you absolutely cannot afford downtime. But I'm guessing there might be some downsides to this approach, right? Nothing's perfect.
You're sharp. The main trade-off is resource consumption.
Hmm.
Creating and maintaining all these separate processes can be memory intensive. Imagine the overhead of managing all those separate buildings.
Yeah.
Yeah.
Okay, so more isolation comes at the cost of using more resources. Is there a way to mitigate that overhead without sacrificing too much isolation?
There is. Oracle offers a solution called shared server mode, sometimes referred to as connection pooling.
Shared server mode, connection pooling. Break those down for me.
Sure. In shared server mode, instead of having a dedicated process for each connection, multiple client connections can share a smaller pool of server processes. It's like having a shared taxi service instead of everyone having their own private car.
Ah, okay.
Yeah.
So it's a more efficient use of resources.
Mhm.
But doesn't that reduce isolation? Are we back to the roommate conflicts we talked about earlier?
It's a balancing act. Oracle is designed to manage these shared resources carefully, minimizing the risk of conflicts. But you're right, it's a consideration. Now, while Oracle uses processes for managing connections, it actually leverages threads heavily within each of those processes.
Wait, so we're going deeper down the rabbit hole here.
Yes.
Processes and threads within Oracle.
Exactly. Let's say you execute a query in Oracle. It might use multiple threads to break that query into smaller parts, process them concurrently, and then combine the results. It's like having a team working together to solve a puzzle, each focusing on a different section.
Ah, okay. So threads are speeding up those internal operations within each connection's process. That makes sense. But I'm still trying to wrap my head around when you choose the dedicated process approach versus shared server mode in Oracle. What factors kind of influence that decision?
It depends on the specific needs of the application. If absolute isolation and fault tolerance are paramount, even at the cost of higher resource usage, then dedicated processes are the way to go. Think mission-critical systems where even a small chance of data corruption is unacceptable.
So dedicated processes are like having maximum security but at a premium price. What about shared server mode? When does that make more sense?
Shared server mode is often preferred when you need to balance performance and resource efficiency. It's common in applications with high user concurrency where you need to handle many connections simultaneously without overloading the system.
Okay, so shared server mode is like finding that sweet spot between isolation and efficiency. It's fascinating to see how Oracle blends these concepts together. Now, I'm curious about how another popular database, PostgreSQL, handles processes and threads. Does it use a similar, hybrid approach?
PostgreSQL takes a different path, stemming from its core design philosophy. Unlike Oracle, which has that multi-threaded architecture, PostgreSQL is fundamentally process-based.
So is it like PostgreSQL is doubling down on the fortress approach, with every connection getting its own heavily guarded tower?
Exactly. Each connection to a PostgreSQL database spawns a new process, and this dedication to process-based isolation is deeply ingrained in PostgreSQL's DNA. It prioritizes stability and data integrity above all else.
That makes sense.
Sure.
But if every connection gets its own process, doesn't that lead to, even more resource consumption compared to Oracle's default setup?
You raise a valid point. However, PostgreSQL has evolved to address this potential bottleneck. One key optimization is, you guessed it, connection pooling.
Ah, connection pooling strikes again. So even though PostgreSQL is process heavy, it uses the same trick as Oracle to share resources efficiently. Are there any other ways PostgreSQL optimizes performance with this process-based model?
There are. Remember how we talked about parallel processing being like a team working on different parts of a puzzle? PostgreSQL has a feature called parallel query execution, which does exactly that. It can break down complex queries into smaller chunks and have multiple processes work on them concurrently.
So even though it's process-based, PostgreSQL still finds ways to get those speed benefits from parallelism. That's clever. But what about threads? We've talked about how Oracle uses threads within its processes. Does PostgreSQL do the same?
While PostgreSQL is fundamentally process-oriented, it does use threads internally. But those threads are mainly for background operations and like housekeeping tasks, not for handling client connections or directly executing queries.
So threads in PostgreSQL are like the behind-the-scenes crew, keeping the theater running smoothly, while the main actors, the processes, are on stage handling the performance.
A perfect analogy. You're really getting the hang of this. Now, I know you're eager to see how this translates to real-world applications. Are you ready to dive into some case studies?
Absolutely. Let's see how these concepts play out in the wild. Okay, case studies. Let's hear about companies using these concepts to solve, like, real problems. Hit me with a PostgreSQL success story.
All right. There's this fascinating case about a company, right? And they were facing major performance issues during like peak shopping seasons. Their MySQL database just couldn't keep up with the transaction volume, leading to frustrating delays for customers.
Ouch. That sounds like a nightmare for any e-commerce business.
Yeah.
Slow website equals lost sales, right? So they turned to PostgreSQL, I'm guessing because of its reputation for, like, rock-solid stability.
You got it. They were drawn to PostgreSQL's process-based model, which ensured isolation between connections. They knew that if one part of the system had a hiccup, it wouldn't bring down the entire site.
Makes sense. But didn't we say that all those separate processes can be, resource intensive? How'd they handle that?
They strategically use connection pooling, just like we discussed with Oracle. By using a tool called PG Bouncer, they were able to limit the number of active connections to the database, preventing overload. PG Bouncer acts like a traffic cop, smoothly managing the flow of requests.
Smart move. So they got the isolation benefits of processes without, like, bogging down the system. Did they do anything else to kind of boost performance?
Absolutely. They leveraged PostgreSQL's parallel query execution feature. This allowed them to break down those big, complex queries into smaller parts and run them concurrently across multiple processes, significantly speeding things up.
Okay, so they use connection pooling to manage the influx of traffic and parallel processing to make those queries lightning fast. Anything else?
One more clever trick. They offloaded tasks like data reconciliation and fraud detection to PostgreSQL's background worker processes. These tasks were initially running as separate applications, constantly pinging the database, which added extra load.
So they brought those tasks, like, in-house, so to speak, to streamline things.
Exactly. By running those tasks within PostgreSQL, they eliminated the overhead of communication between separate systems, further improving efficiency.
This is a great example of how choosing the right tool for the job and using it strategically can make a world of difference. Now, for contrast, tell me about a company that rocked Oracle's strengths.
Okay. This case involves a company handling like real-time transactions, fraud detection, and compliance reporting, right? For millions of accounts. They needed speed, efficiency, and scalability all at the same time.
Talk about high stakes. I'm guessing a single glitch could have, like, massive consequences.
Yeah.
So how did they leverage Oracle's strengths?
Their first move was to implement shared server mode for connection management. Remember how we talked about this being like a shared taxi service? It allowed them to handle a huge number of user connections without creating a dedicated process for each one, saving precious resources.
Efficiency through sharing. But didn't we say shared server mode could potentially lead to conflicts?
It's a trade-off, but Oracle is designed to handle this gracefully. And to boost speed even further, they used Oracle's multi-threaded query execution capabilities. This allowed them to break down their complex queries and run them in parallel across multiple threads within a single process.
So they were hitting that speed boost from both processes and threads? Anything else in their arsenal?
For ultimate scalability, they deployed Oracle's Real Application Clusters, RAC. This allowed them to create a cluster of interconnected servers that acted as a single, super powerful database system.
Okay, RAC sounds intense. It's like having a team of synchronized swimmers working together flawlessly. How does this help them?
RAC enabled them to distribute their massive workload across multiple servers, ensuring high availability. No single server was a bottleneck, and the system could handle enormous traffic without breaking a sweat.
These cases are awesome. We've gone from theoretical concepts to companies actually using these tools to conquer real challenges.
It's amazing to see it in action, right? But before we get too carried away, let's zoom back out and make sure our listeners walking away with the key takeaways.
Good idea. So to recap, we started by diving deep into the difference between processes and threads. Processes are those independent units with their own space, like separate departments, great for isolation and security. Threads, on the other hand, are those speedy roommates, sharing the same space, perfect for fast communication and collaboration, but requiring careful management.
Exactly. We then explored the trade-offs between these two approaches. Processes for robustness, threads for speed, and emphasized that most modern systems, including databases, use a hybrid approach to get the best of both worlds.
We also dug into how two of the most popular database systems, Oracle and PostgreSQL, use these concepts in their own unique ways. Oracle, the master of multi-threading, and PostgreSQL, the champion of process-based stability, each have their strengths.
And we learned that there's no one-size-fits-all answer. The best choice depends on the specific needs of the application, the workload, the budget, and a whole host of other factors.
Yeah, the real-world case studies really brought all of this to life. Seeing how companies are using these concepts to solve complex problems is incredibly inspiring. It shows that understanding the fundamentals can lead to some truly innovative solutions.
Absolutely. And for our listener, remember, this is just the tip of the iceberg. The world of software development is vast and constantly evolving. But understanding the foundational concepts of processes and threads is a huge step towards navigating that world.
Couldn't have said it better myself. Keep exploring, keep asking questions, and keep pushing the boundaries of what's possible. Who knows? Maybe you'll be the one featured in our next case study.
Until next time, happy coding.